Hi. Now in this question we're given the first three terms of the geometric series. They're k plus 4, k and 2k minus 15, and we've got to show that k squared minus 7k minus 60 equals 0. So how are we going to do this? Well, what you've got to remember is essentially that if you've got the terms of a geometric series, let's say the first term is a, and we multiply it by a common ratio, then the next term would be AR, where R is the common ratio. And if you multiply this by R again, you're going to have AR squared, and so on. Now, if you divide any term by its previous term, like the second term here, AR divided by A, you get the common ratio R because the A's cancel. This is also going to be exactly the same as taking, say, the third term and dividing it by the previous term, the second term, AR squared divided by AR. In this one, the A's cancel and R goes into R squared R times. So each of these are equal to the common ratio R. So it is this idea that we use, okay, to find this equation. What we need to do is simply divide any term by its previous term, and that will be the common ratio. So k over k plus 4 must equal this term here, 2k minus 15, divided by its previous term, k. Now, all I need to do is to multiply both sides by k plus 4. So if I multiply the left hand side and the right hand side by k plus 4, let's just write that in here, 2k minus 15 all over k, then what we see is that this cancels out with this one and k cancels out with this k here, and so if we put that in brackets there, all we need to do is just expand this and we get k squared equals, and then we have k plus 4 multiplied by 2k minus 15. And so expanding the brackets we get 2k squared, I should say, k times 2k squared, and then k times minus 15, minus 15k, plus 8k here gives me minus 7k, and then 4 times minus 15 is minus 60. And if I subtract k squared from both sides, then I'm going to get 2k squared minus k squared leaves me with k squared, and then we've got minus 7k minus 60, and that will equal 0. And that's what we had to show. Alright? So I hope you've got the reasoning behind this, and that brings us now to the end of this part of the question.